So it's a continuation of the first lecture of the transportation problem. In the last lecture, we end with exactly in that place the total number of constant and this. Now we move to the next point for a balanced transportation problem. What is the meaning of the balanced transportation problem? First, we recognize the meaning of the balanced transportation problem. Okay, so balance means how many number of quantity produced in a company that should be supplied for the corresponding destination point. That means that if the total supply equals to total demand, then we say that the transportation problem is a balanced transportation problem. Okay, so here in the previous formulation, when we just write it as a general form of a transportation problem, right? The formulation of a general form of a transportation problem may be balanced, may be unbalanced. But if we consider it in the balanced transportation problem, in that case you can easily recognize that total supply should not be less or equals to this. That means the company, how many number of production produced in a particular company, they should supply every production to the to some extent of destination point. That means this becomes equality sign. And how many number of quantity is demand for a particular destination point, they should not store more than their demand, because it's a very critical situation. You can easily observe the situation is that under COVID-19, যদি আমরা এরকম করে ভাবি কোভিড-19 কেসে বাজারে প্রচুর রকমের একটা ক্রাইসিস দেখা দিচ্ছে, আর্টিফিশিয়াল ক্রাইসিস, যে যে মানুষের ধরে নাও 25 কেজি চালে হয়ে যাবে, সে ভয় পেয়ে আরো 25 কেজি বা 30 কেজি চাল সে কিনে স্টোর করে রাখছে বাড়িতে। স্বাভাবিকই চালের ক্রাইসিস দেখা দিচ্ছে, এবং যে ডিমান্ড, যারা সাপ্লাই দিচ্ছে তারাও আর সাপ্লাই দিয়ে উঠতে পারছে না। তার মানে যদি ব্যালেন্স প্রবলেম হয়, তাহলে আমার যদি 25 কেজির ডিমান্ড থাকে, ইফ আই এম দ্য ডিমান্ডিং পার্সন, if we haven't demand of we have a demand of 25 units, then we just stock exactly in 25 units. So in that case, this should not be greater equals to this. It's represent the number of quantity stored in their destination point is the required number of quantity they require, but still they store more than the required number of quantity. But if it's a balance problem, that should not be greater equals to, that should be equals to. Exactly for that reason, in a balanced transportation problem, we always consider the equality sign. The question is that why we consider the balance problem? Because if the problem is not a balance problem, you cannot solve the transportation problem. That means if the general life problem, most of the general life problems should be unbalanced, then our goal is to carry how can I reduce a unbalanced problem to a balanced problem. That's a very important case. First we move to the technique to solve a balanced problem, and then we move to the technique to reduce an unbalanced problem to a balanced problem. That is the step. To solve a transportation problem, we need to two step. When you solve any transportation problem, you need to two steps. One is the northwest corner method. First step is to find the initial basic feasible solution. It's again a simplex method, but still we should not use according to the tabulation form of the simplex method usually we use, but it's a different form of the simplex method. So when we start a simplex method, you can easily recognize that we first start with the initial basic feasible solution. When we use some slack or slack variable or surplus or artificial variables to start the problem with a slack variable, and according to the demand of the problem, we start the problem with some artificial variable. Okay, so the first step is to find the initial basic feasible solution. You can easily find the initial basic feasible solution using three methods. Too many methods are in this chapter, but according to our syllabus we will discuss only three methods. One is the northwest corner method, another one is the matrix minimum method or minimum cost method or least cost method, to the different name of this method. Another one is is the Vogel approximation method. It is known as the VAM method. It's the most valuable method for finding the initial basic feasible solution. Again we repeat, it's the most valuable method regarding to find the initial basic feasible solution. Okay, so and the second step, it is to check that the solution is optimal or not. You can check the solution is optimal or not using two different methods. One is the stepping stone method, another one is the MODI method. The full form of MODI method is modified distribution method. It is also known as the UV method. So regarding this lecture, we start to learn to find the initial basic feasible solution using northwest corner method. That is a problem. We find the initial. First we have to check that the problem is a balance or not. According to the construction of the problem, which we'll already discuss in the graphical representation and the corresponding tabulation representation, this one is the table. Just to find the initial basic feasible solution of the given transportation problem using northwest corner method. Here is the demand, here is the supply of the factory, and here it's represent the demand. Here the total supply is 40 plus 25 plus 35, that is 90, and 25 plus 35, it is 60 plus 40, 100, and this one is 30 plus 30 plus 40, that is 100. That means the total supply is 100 unit and the total demand is 100 unit. So it's a balanced transportation problem. You can start to make the initial basic feasible solution to find the northwest corner method. So here we use according to the naming of the method. It's very important. According to the naming of the method, it's very important. Again we repeat, the northwest corner method. It's a northwest corner method. In this table, this is your north side, north, this one is your south, this one is your east, and this one is the west. Not west, it's west, it's west, northwest corner method. So your problem should start from here. Okay, this one is your northwest corner cell. So your problem start from here. The question is that how can I input here 30? It's very important. So it's a period, it's a very tough period for you as well as for us. You just move in a shop and you required say 30 kg of rice, but the shopkeeper says I have 40 kg of rice. Then what to do? You just pick 30 kg rice and move to your home. Am I clear? তুমি একটা দোকানে গেলে, তুমি বললে আমার 30 কেজি চাল লাগবে, দোকানদার বললো আমার দোকানে 40 কেজি চাল আছে, তাহলে তুমি কি করবে? 30 কেজি চাল নিয়ে চলে আসবে। আরেকটা হতে পারে যেটা, সেটা হচ্ছে তুমি দোকানে গেলে, তুমি বললে আমার 30 কেজি চাল লাগবে, দোকানদার বললো নেই, 20 কেজি চাল দিতে পারবো, তখন তুমি কি করবে? 20 কেজি চাল নিয়ে চলে আসবে। Exactly we use this concept to import this quantity. Okay, so we start. Here it's the supply. The first factory can supply this cell represent the first demand point, first the destination point deserve to fulfill its demand from the first factory. Okay, this one is your first factory. The first factory supply is 40 unit and the first destination point demand is 30 unit. Out of this 30 and 40, the minimum is 30, so here we input 30 and 40 is out of this 40, 10 units is remaining, so here we write 10. Okay, exactly for that's why we write here 10. The second, so you have to cancel this row. Okay, now the northwest corner is this. So the first factory can supply 10 unit and the second destination point has 30 unit requirement, so the 10 unit should fulfill by the first factory and 20 unit is remaining for the demand, so here we write 20. Since the factory fulfillment is complete, so you have to delete this one. Now the northwest corner is this. So the supply, as the second factory can supply 25 unit, and the second destination demand is 20 units, so here we write 20. So the remaining quantity can supply from the second factory is 5 unit, so here we write 5. Since the second demand point is completed, so we delete this or cut from this table. Now the northwest corner is this. The demand is the supply is 5 unit and the demand is 40 unit. So 5 unit is input here, and the remaining 35 unit is made by the first third factory. So this one is the procedure. That is the procedure using northwest corner method. Okay, so how can I write the initial solution? It's very important. The initial solution, you can write the input here x11 is 30, where you cannot input anything. That means this position x13 position, that should be 0. You should not write this one. Only we write where the input is given. That means x11 is 30, x12 is 10, x22 is 20, and x23 is 5. Okay, so here we write exactly this. Remove everything. X11 30, x12 10, x22 20, x23 5, and x33, that is 35, and the remaining cell becomes 0. That means they are not the suitable position. For this, the costing should be, how can I find the costing? It's the initial costing. Again we mentioned it's a initial costing, it's not the optimal costing. Before we check the optimality, you cannot say that should be the optimal solution. Here the optimal means is the least solution. So we can find the solution 30 into 8, 10 into 9, 20 into 3, 5 into 5, and 35 into 6, because this represent the unit cost, and this represent how many number of quantities supply from a particular destination point to a particular supply point to particular destination point. Regarding this, the solution becomes exactly 625. Here we calculate the solution. So it's a procedure for northwest corner method to solve, to find the initial basic feasible solution. I am not mentioning it's the optimal solution. It would maybe happen that after checking the optimality, it may be a optimal solution. I cannot interpret previously without checking the optimality. So wait for the next lecture. We will move in the next lecture. We will learn the second method to find the initial basic feasible solution, that is matrix minimum method, and the third method is the Vogel approximation method.